Hi, everyone. Welcome to OpenInfra Live, the online webinar hosted by the OpenInfra Foundation, talking about all things open source infrastructure. Today, we have our first episode of 2024, and I'm excited to be here. My name is Allison Price, and I will be your host for today. We are streaming live on YouTube and LinkedIn, and we'll be answering your questions throughout the entire show. So feel free to drop questions in the comment section, and we'll answer as many as we can. Today, we are joined by the leaders of OpenDev, a collaboratory for open source software and development at scale. They'll be talking about how you can leverage and contribute back to the OpenDev community. Please join me in welcoming Jeremy Stanley, Jim Blair, and Clark Boylan. Hello, everyone. All right, I'm going to kick it off to y'all so y'all can talk about what OpenDev is and the history of how we got to where we are today.
I guess I can jump in there. So OpenDev really, the origins of it are lie with the OpenStack project. I guess probably late 2010. I know Jim was around at the very beginning. I and Clark did not come on until I guess 2012. But basically the OpenStack project was very popular, very active, new open source project, and needed a fair amount of collaboration infrastructure to really help the developers who were working on it coordinate to be able to produce the software there at the beginning. And so, people with experience in other open source projects were being brought in to kind of help shepherd this newly forming project, provide some context and open source ways of working and so on. And so they applied that to the infrastructure that was being used to collaborate as well. And in particular, I know some of the early people working on the infrastructure came from an open source project called Drizzle, which was a database, relational database server. And they had an egalitarian approach to code review and testing, and basically the idea that whatever merges to the revision control for that project should be fully working, rather than testing things after they land and finding out that stuff's broken and then having to figure out who broke it and go back and so on. So that was basically from the beginnings of the OpenStack project. The idea was that all of the changes that were being proposed to the various components of OpenStack would go through a battery of code review and testing before it was allowed to merge the repositories. So that required a fair amount of infrastructure. We were, I guess, at the very beginning using Hudson, which later forked to become Jenkins. Created the Zool project pretty soon into that to start coordinating the activity that was a little bit too intelligent for Jenkins on its own to manage. Over time, we kind of needed to scale some of that out. We were also running mailing lists, a meet bot for the projects to be able to have automated minutes of their meetings that they held in IRC and so on. So that was sort of the very beginnings. I don't know if anybody has anything to add to that.
Yeah, I think. Oh, go ahead, Jim.
Go, Clark.
I was going to mention that I think one of the other important ideas that were brought along in the early days is that open source tools were important for what the project was doing. So, very early on at that time, the CI system was open source, Hudson and Jenkins, and the code review system, Garrett, is an open source tool, and the mailing lists were built on Mailman, all open source tools. And so there was a kind of, from a very early beginning start of the project infrastructure for OpenStack, there was this strong idea that we should rely on open source tools as much as possible to get the work done within the OpenStack project. And then at the same time, we were relying on infrastructure donations from donors, for like cloud hosting companies. At the time, Rackspace and HP Cloud. And that kind of also continues today, where we're working with different cloud providers and cloud systems to run and build these services.
How many clouds is OpenDev up to now?
Depends
I
on if
think
you
it's
count
varies
providers
from
or
day to day.
regions, but
Yeah.
It's around 6, I think.
Yeah.
six different providers. Yeah, I think we've got, if you count individual regions, it's probably close to double that.
Yeah. So just to kind of jump ahead a little bit, it's from an operational point of view, it's kind of neat that we treat the entire service as a multi-cloud application, and that directly comes from the way that this was started as relying on these donated cloud resources, because that's constantly changing. You know, new folks show up and add resources. You know, resources disappear or become less suitable for us for some reason, and are removed, and we just roll with it. And so, but going back to what Jeremy said, I think a lot of the character of OpenDev and the nature of the services that we run really goes back to that one idea that we call project gating, and that was, you know, what Jeremy described as every change that merged to the Drizzle project had to pass tests before it was merged. They put that in as a hard rule for that project, and when those folks came over and started working on OpenStack, like right at the beginning, they said, let's start with this rule in place. And really, OpenStack, the development process and community of OpenStack developed around that. It's a really great way to work, and if you can get that rule in place early on in a project, that's great. The earlier, the better. You can always retrofit that later on. You can always say, well, you know, starting from now, we're going to make sure that nothing merges unless it passes tests. But you know, it's always a little bit of an uplift, and the reason why is the reason for the rule in the first place, which is that if you don't do that, your tests are inevitably broken in some way, right? And that's what slows down velocity on larger projects. That's, you know, if somebody merged a change because they knew it worked well enough, right? And so what if a couple of tests are broken, right? Well, those couple of tests are preventing somebody else from doing their work at the same time. So if you have a rule like that in place, this project gating rule, then it means that you can develop at full speed and everybody else can develop at full speed at the same time. And that's really what was needed as OpenStack was growing, because the OpenStack project started as two independent projects that sort of got put in a room together and said, hey guys, you're OpenStack now. But in that room, everyone saw that the future was going to be more and more projects taking on more and more of these cloud services. And so it was very much, how are we going to grow the development process and the community together to do all of this? And that kind of thinking that we need to keep everybody working at high velocity and working independently yet towards shared goals, really drove a lot of those decisions.
Yeah, I mean, the ideas behind project gating are actually not all of that surprising to people today, but certainly 14, 15 years ago, this was extremely novel, and I think it really goes to show how effective that approach was that that at the time when it was virtually unheard of in an open source project to work that way. It's now how a lot of large open source projects operate, and we did a large part of the proving that it was possible.
We also talked about it at a lot of conferences over the past decade. So we've been out there sort of touting the benefits of this for a while. So I think it's been great to share that experience and help promote the idea out in the world.
And I think if you're an open source project, this is even more important for you because most of your developers probably aren't all sitting in one office together or in the same time zone. And so they can't walk down the hallway and be like, hey, this test broke. What happened? Oh, I checked in this thing. Sorry. And, work it out. It's a lot more asynchronous, and the time delays involved for things being broken are larger. And so it's important to keep everything working so that the global community involved in these projects can kind of keep rolling forward, which is probably a good, lead into how OpenDev came to be, right? We've talked about how there's this OpenStack tooling and development process and structure, and essentially what happened is that there was a realization, and I think we knew kind of early on that this is useful beyond OpenStack, and we would like other people to be able to take advantage of these tools and use them for their projects, whether they're OpenStack or not. And so very early on, there was a concept that we called StackForge, which was essentially kind of like the very early beginnings of OpenDev, where the idea was we can provide these tools to projects that aren't OpenStack. And that, for a number of reasons, kind of petered out. The hosting for that was a little odd, and things had to get migrated and moved around. And eventually we realized, no, we should be focusing on that and making it possible for kind of StackForge to live beyond where it had been. And that's where I think we ended up with OpenDev is a bigger concept of, OpenDev hosts OpenStack rather than the OpenStack infrastructure hosting other projects.
And back to Clark's earlier point too about the importance of open source tooling, I think it's been really one of the biggest drivers in our design choices. At the very beginning, OpenStack development was happening to a large extent with Bazaar and Launchpad, and the people involved in the project saw that Git was really the future of revision control. It had its flaws, but it was gaining in popularity so rapidly that that it was obvious that the project was going to need to migrate to Git. And I know GitHub was still pretty new at the time, and it was looked at, but really a large part of why we ended up using Gerrit was because Gerrit is open source and GitHub simply is not.
There were also technical reasons. There were actually at the time we would not have been able to implement the project gating rules and the code review process that we were already using on Launchpad with Hudson. We looked at doing that with GitHub, and it wouldn't have been possible at the time. They've since added features that do make that possible, which is switching hats here for a moment. So I wear a lot of different hats. I help maintain the OpenDev infrastructure, but I'm most focused on the Zool project, which is the project gating system that we've spun out of all of this effort. So putting on my Zool hat for a moment, one of the things that we've done with Zool since the early days of all of this is we've expanded the code review systems that we support. So Zool itself supports not only Gerrit, but also GitHub and GitLab and Pagure. So that's been good for folks that want to take the code review and project gating methodology to these other systems with their own self-hosted Zool inside of their companies or whatever. But So it's been good to see that I guess that way of working gain enough acceptance that basically you can do it with any of the code review systems now. But just to be clear, OpenDev is still very much focused on just the resources that OpenDev provides. So OpenDev runs Azul and it runs a Garret, and basically the Zool that we run is in service of the projects on the Garret that we run inside of OpenDev.
I think it also. It also says a lot that the advanced workflows that we were relying on didn't become possible in GitHub until a decade later. But we were able to do that with 100% open source long before that was possible on their proprietary platform.
Right, and I think that's an important thing to note, is that as this kind of infrastructure we built kind of morphed from the OpenStack infrastructure to OpenDev, we've continued to keep a lot of those strong principles, right? Like we want everyone to do project gating on the hosting that we provide, but we also want to continue using open source tools to run these services, and we're still using Garret because it's open source. We're using Zool. We build Zool with the Zool maintainers and so on. So while we've changed kind of the branding around what this is to be hopefully more welcoming and inclusive to other projects, because not everyone wants an OpenStack banner over the top of their project, which totally understandable. But we haven't left those kind of principles behind, right? Like this is the development process that we believe works well for open source projects. And we also believe that open source projects should be using open source tools. And so we continue to build and run and deploy those tools for open source projects.
So we actually had a question that I think is really interesting, and the blog may go into it, but I think it would be fun for y'all to answer live. So Song Soo, one of our OpenInfra Korea user group leaders, he said he remembers that Jenkins was a CI for OpenStack a very long time ago, and wondered what inspired y'all to create Zool for the CI for OpenStack and other open source projects.
Yeah, well, why don't I go into that a little bit? And yes, that blog post is a great resource for some of this information, and I definitely encourage folks to sort of follow up and read that. But I'll give my sort of oral history of that. So we and just to be clear, we're actually I'll speak for myself, and I think at least some of the other maintainers. We're big fans of Jenkins. We really like Jenkins, and we consider them our open source friends in the CI space. Some of us have actually contributed pretty significantly to Jenkins in the past. And basically what was going on is we were using Jenkins to implement this project gating process. And as we began to do that more and more, it became clear that the structure inside of Jenkins wasn't really suitable for that, especially once you start using multiple projects. So as the OpenStack project grew and we added more than just those initial 2 projects, what we were faced with was this struggle of, well, we want to make sure that nobody breaks. We want to make sure that every change is tested before it merges. Okay, that's not too hard to do with Jenkins, right? But then we had 2 projects that interacted with each other, and we wanted to make sure that if we merged a change to one of the projects, it wasn't going to break a different one. That was a little bit harder to do with Jenkins. We managed to find a way to do it, but it was starting to stretch Jenkins' capabilities a little bit. And then we added more projects and more developers, and the rate of changes increased. And at one point, it was taking like an hour to run the tests for the entire OpenStack system. And there are 24 hours in a day, which means we could, across all of the projects that we had, All we could ever do was merge 24 changes in a day, and we kept adding more projects and more developers. And the math is pretty clear on that. We weren't going to be able to sustain it. So we started to have, we basically needed to move beyond Jenkins internal scheduling. But we were really tenacious and we really liked Jenkins. So we actually, we did kind of a crazy thing. The first version of Zool was actually just an external scheduling engine for Jenkins. And what it would do is, instead of letting Jenkins decide when to run jobs, the first version of Zool would just tell Jenkins to run jobs and then use the results of those to make its own internal decisions about gating, and it would decide when to merge changes and whatnot. So we kept using Jenkins to run these jobs, but the decisions about when to run them and how to run them and what changes to include in them were all moved out into Zool. So Zool became the gating system, Jenkins became the job execution engine. We did even more crazy things as we continued to scale. I think we probably made the world's first multi-master Jenkins system by hooking up to the Gearman job scheduling system. So what we would do is we'd have Zool put jobs on this Gearman queue, and then the various Jenkins servers that we had would pick up the jobs from them. And so we actually had like a fleet of 8 Jenkins servers at some point, all basically top level Jenkins masters. Each of those had 100 different nodes that they would run jobs on. So that at some point we were like, okay, well, we've really pushed Jenkins as far as we can. We're not using the features in Jenkins for this anymore. And so we took the plunge and replaced Jenkins as the job execution engine with Ansible. And so now, at this point, Zool is completely separate from Jenkins. It's its own project gating system that uses Ansible to execute its workloads. So that's kind of how we grew out of Jenkins, both in terms of scale and our workload needs, and ended up making Zool, and then making Zool its own standalone project.
Yeah. Also, I would say a big part of that late push into putting more logic into Zool was because when you started having multiple Jenkins servers, you could no longer rely on the Jenkins dashboard because it was spread across all of these different servers, and you had to figure out which server had run which build. And same thing with log hosting. Like, now you needed to aggregate logs from somewhere. So basically we needed a separate dashboard that provided an overview of everything that would have been on all the individual Jenkins dashboards, and log hosting that was effectively disconnected from the Jenkins servers themselves and aggregated all of that. And so really, once you've taken out the web interface and the log hosting and everything else, there wasn't a whole lot of Jenkins left in the picture.
I guess one thing that Jim didn't touch on in kind of the history of Zool is how it was a scheduling engine for Jenkins, but from day one, it was a scheduling engine that understood how to do project gating, and that was modeled after CPU speculative execution, right? So there was some outside influence into the design. I think I seem to recall there was like an IRC message one day where Jim's like, "Look at this cool thing I did."
Yeah, there was kind of going back to that thing where we're like, oh, there's 24 hours in a day and it takes an hour to run tests. How are we going to solve that problem? And yeah, what Clark was saying is we took a page from the flagship feature of the Pentium processor, right, which was speculative execution. And we said, well, what if we were optimistic and assumed that all of these tests are going to pass? What we could do is just stack up a series of changes that we're going to merge together, run tests for all of them in parallel. And if they all pass, then we can just merge them all at the same time. So imagine taking 10 changes and you run jobs for all 10 of them at the same time. They take 1 hour. At the end of the hour, you merge all 10 changes. So that's sort of how we increased our throughput without actually reducing the fidelity of the information that we provided back to developers. We're still running tests on every individual change, so that we can, if there are any problems later, we don't have to bisect them or anything like that. We know that each individual change works alone, which is, from a development standpoint, that's really nice, because at any point you can revert any single change if you run into problems later. You don't, it's not like that batch of 10 changes has to be reverted together or bisected to figure out what's going wrong. You know that every change to the project is a valid change that stands on its own. But so we were able to still provide that guarantee to users, but increase the throughput at the same time. Then, of course, if one of those jobs does fail, then we've lost some time. We have to restart the jobs. We reorder the changes to remove the failing change, that sort of thing, and restart. But that's still going to be less. The worst case for that algorithm just ends up being the base case for the algorithm that we had before on Jenkins, which was run every change serially.
So I was thinking, so I know we've gone through like the history and a lot of the different components of how we got to where we are, but kind of wanted to get talking about like the nitty gritty. Like, how do you actually operate these services? Like, what goes into it from a community perspective?
Yeah. So I think a very important part of what we do in running the services is that we actually dog food the services. So what I mean by that is we use Gerrit and we use Zool to deploy Gerrit and Zool. And sometimes this can create problems where, you've got dependencies that are annoying because, how do you restart Zool if Zool is responsible for restarting Zool is kind of the classic. But what that means is we're using these same tools. We know how they work. We want to make them better, not just for you, but for ourselves. And we're doing everything in the open on top of those tools, because Gerrit is doing code review for open source projects like OpenStack. When we do code review for OpenDev in Gerrit, it's out in the open. Anyone can review it, just like you can for, say, OpenStack or Zool or Starling X. And what that means is, you don't have to be an OpenDev root administrator to get involved and say fix a bug in a system or improve some feature in one of the services we deploy. You can go out and make those changes, propose them just like you would to any other project we're hosting, and then the configuration management will take care of it once things are approved and merged. I don't know, Jeremy, do you want to talk a bit about the configuration management?
Well, it's I would probably jump in first and say I think this is an excellent demonstration, maybe even the flagship demonstration of the complex capabilities of Zool as a CI and CD engine, because we are effectively able to propose changes for our configuration management and orchestration, see them work in mock-ups effectively of the services that they would normally deploy, and then if they work and if we're satisfied with them from a review perspective, then Zool itself is deploying those same changes automatically once they get approved. So it's really an end-to-end management of the services themselves, where we can test every single component to make sure that we're not going to break them before we merge a configuration change or an automation change or whatever. So it's from a systems administration perspective, it takes a little bit of wrapping your head around, but it's really freeing to have this sort of automated. I mean, like in a traditional systems administration environment, you would have, say, a test environment, and you would deploy your proposed changes to your test environment first, and then exercise it and make sure that that everything worked. And once you were satisfied that it didn't break the test environment, then you deploy it to your production environment. And then the next time you wanted to test something, you'd have to go reset your whole test environment and start all over. And so with Zool, we basically get all of that automatically, because it's creating ephemeral test environments on the fly whenever we want to test a proposed change. And we get the interdependency support. So if we are proposing a change for, let's say our meat pad infrastructure, for example, we've got systems that we host that are integration of Jitsi Meet video conferencing and Etherpad collective collaborative documentation editing. And we can test whether a change that we're considering making to Jitsi Meet is going to break the integration between Jitsi Meet and Etherpad. So even though those are being run as distinct services, the integration between them is still testable, and we can even order changes that we're making to both systems and make sure that that sequence of changes to both Jitsi Meet and Etherpad configuration collectively aren't interfering with the integration between those. Yeah, from a nuts and bolts perspective, again, we've got similar choices to what Zool itself uses internally. We're using Ansible to orchestrate all of the configuration and restarting of services and so on, which again provides a nice integration from a Zool perspective, because we can reuse those same deployment playbooks as basically job execution payloads for testing the services in the same way that they'll be deployed. I think that's probably a key principle of the modern design we have for OpenDev, is that we test things the way that they will be deployed. Not, I mean, to the extent possible. Obviously, we have some placeholder credentials, and we may create self-signed certs for some things and whatever when things are being tested. But as much as is feasible, the same automation that will do the production deployment is used in the testing of those configurations and automations.
I'm back, which means we have a question from the audience. And I think this one fits in nicely with what y'all are talking about right now. So is Zool gating plus Garrett the first in the sense of automated battery of tests plus code review / CI at large scale?
So I think there's a, I guess in our conception of the development process, we actually, I would say it's kind of review centric, right? So we see the code review system as the nexus for ensuring that a change is suitable for merging. So when somebody uploads a change to Garrett, a lot of things can start to happen at the same time. Other developers who are working on the project can look at that change in Garrett and start performing code review, so they can start making decisions about whether that change is a good change for the project, whether it fits the overall direction, whether it's a good technical implementation, things like that, right? All these sort of human decisions about whether a change should be merged or not. And then at the same time, Zool starts running the automated test suite for the project, and potentially integrating it with any other changes that it depends on, and things like that. So for most of the projects hosted in OpenDev, they're pretty significant in terms of size and complexity. So that might take an hour or more to get that those initial test results back. When those are reported back, they're reported back to Garrett as well. And so what we're trying to do is we're trying to present all of the information about a change to the developers who are maintaining a project inside of the Gerrit code review system. So that's kind of how they work together, and how they feed this process of deciding whether or not to merge a change. Once those automated tests look good, and once the humans have looked at the change and decided it's a good idea, then at that point they approve the change, and that's the signal for Zool to go out and actually try to merge it. So it runs tests again, and just in case anything has changed in the meantime, so that at that point it knows that that last set of tests that it runs are going to test the change exactly as it's going to merge. And if they pass, then Zool will cause the change to be merged inside of Gerrit, and it goes into the Git repo. So they really work together that way, all in service of the developers who are maintaining the project.
If the question was more about the history and whether our use of Gerrit and Zool together is the earliest example of combining code review and automated testing at a large scale, it's probably one of, like we mentioned earlier, the Drizzle project had something similar set up at the beginning before OpenStack existed. To some extent, the popular Linux distributions, Ubuntu, for example, had something not too far off from the concept, which is why Launchpad kind of existed and had integrated automatic package building and so on, and had its own revision control built in. But I think as far as what really kind of made this combination we were using somewhat novel was that it was again very focused on code review, whereas a lot of the previous test automation approaches did not have nearly as much of a code review centric approach.
I think among open source projects, it probably was the first large one. I'm not aware of any.
Firefox.
Yeah.
Firefox had something not quite the same, but fairly largish scale it kind of concurrently. But they didn't do project gating. So yeah, that's why I say it's not quite the same, but they did run lots of tests, and it was kind of code review centric, but not quite integrated in the same way with project gating.
Yeah.
And we tended to see a lot of open source projects doing one or the other, but not necessarily combining them the way that we did. Gerrit came out of the Android project and their need for extensive code review, but they didn't really have their automated testing tied into it quite so thoroughly as what we ended up with.
Yeah. And there's sort of occasionally you might hear about companies that have some of these features internally in their own systems. I can think of a few sort of famous tech companies that are rumored to have something fairly sophisticated in terms of how they do their testing and development. I think one of the things that we've heard from folks working in the industry is that this combination of well, especially Zool, but Zool with any of these code review systems, is as close as you can get in the open source world to the sort of fabled internal testing suites in some of the large tech companies. Perhaps it even surpasses it in some ways. It's a little hard to know. Some of these companies are pretty tight-lipped about it, But the fact that, as Jeremy described earlier, the fact that in OpenDev our process for making a change to our production system is to, in fact, have an automated system spin up an entire ephemeral copy of that infrastructure to test that change in an automated way, destroy it at the end of the test, report the results back to the user, and give the folks working on the system basically complete confidence in deploying a change before it happens, because our test system is so exactly like production, and we have an infinite number of test systems that anybody can cause to be created just by writing their own change. That's extremely powerful, and I think it is. If it doesn't surpass, it equals what is available in some of these large tech companies, what they're doing privately. So I think having an open source project that can do that, and then having something like OpenDev as a public demonstration of that is wonderful.
And one of the most important features to me that enables is that anyone who wants to help us with the management of these systems is able to do that through public submission of proposed changes, code review. They can help review configuration changes that are proposed by other users, and so on. And so it again allows us to sort of crowdsource the management of all of these services by engaging the community who are relying on them to help with their management.
Going back to the actual kind of nuts and bolts of how we're deploying things, Jeremy mentioned we use Ansible. So Ansible is the kind of configuration management system that we use. And if you're familiar with, say, OpenStack Kala, we're using Ansible to deploy container images of our services. And this ties back to what we were just discussing of how we have these ephemeral environments and so on. We also have ephemeral container images where you can make changes to the container image. A new container image will be built and tested in those ephemeral environments to ensure that things are working the way you expect it to before anything merges. And so you don't have to make a change to your container image first, push that up to, say, Docker Hub or Quay key, and then pull it down in your tests. Everything is happening together in a pre-merge environment, which just builds your confidence that you're not going to break anything, right? If you had to update the container image first, you'd worry that maybe you'll accidentally have some automated system pull down that container image and deploy it early. We don't have those concerns because everything is happening in that ephemeral environment before we take the plunge by saying we approve this, please merge it and deploy it.
And by taking advantage of Zool's cross-project dependency support, we can even do, sequence changes to different layers of a multi-layer container image, or to the software that we're going to be putting in the container, as well as the configuration of the container image itself, and test all of that together across multiple different Git repositories.
Okay, so it's nice getting kind of into the nuts and bolts of like, how does this actually work? So if, people are out there and they're like, this sounds really great, but like, what is the actual tactical way to start using, the OpenDev services? Like, what is the best way to start exploring what that actually looks like in a real life scenario?
So there's probably a couple approaches you could take. The easiest is most likely going to be to contribute to one of the projects we already host. You just create an account, push some code, then you can see the code review system in action as people review your code. You can see the CI system in action after it runs tests against whatever you've proposed. So that includes changes to OpenDev. I think it'd be great if people were interested in OpenDev and then maybe they just contributed, like, oh, hey, here's a typo somewhere or whatever. That will expose you to a huge amount of what we do through the process of getting the code contributed, tested, merged, deployed. Another approach would be to just take the plunge. You could say, I've got this project and I'm going to host it with you. I think this is probably more applicable to people who are familiar with Gerrit and maybe Zool because they've used it in other places. I think it is worth noting that Gerrit has a different workflow than say GitHub or GitLab, and so you want to at least be somewhat familiar with how things differ. We think, or I think at least, that the Gerrit workflow works really well, but it is worth being aware that it is different. It's much more focused on, say, code review than just generalized software. I don't know. I don't want to misdescribe, say, the GitHub workflow, but GitHub is kind of more generalized in say hosting a project. You may or may not use code review. You may or may not even use an issue tracker or the wiki or whatever. It's a lot more flexible in terms of how you want to use the tool. Whereas Gerrit has an opinion that when you contribute code, every logical change is a unit of code review, and that unit of code review is a Git commit. You can have those Git commits and changes in a series, and each one will be reviewed kind of in sequence, versus say a pull request in GitHub, where you can have a bunch of commits in a single pull request, which is reviewed together. And so there's just slight differences in kind of how you approach using the tools. But once you're familiar with them, I think, I like to say that using Gerrit isn't any more difficult than using GitHub. It's just a matter of familiarity. You're using the same tools. You're using Git. You're using Git push. It's just, where are you Git pushing? What is the website you're looking at? And then being familiar with the workflow is I think, where people get tripped up. And so just, if you want to get involved, have a little bit of familiarity with it, and you can dive in. Another way to do that is we have a sandbox repo, which just kind of lets you poke at the tools. You can fetch that down, push a code review change up. It will get tested, though whether or not the tests pass, I don't know. It's kind of the sandbox is a little bit of a free-for-all where you can, we don't place the same stringency upon that, say, as our production code. But the idea is to get you familiar with the general workflow and see how things work.
Also, we do provide some extensive documentation in our info manual about these workflow patterns, also general concepts, things about adding new projects, process documentation, and so on.
A lot of the design in more recent versions of Zool has been directed to sort of make the CI system as self-service as possible, and that comes directly from the fact that we as OpenDev administrators actually don't want to have anything to do with what jobs are running on the projects that are hosted in OpenDev. So there's no CI team that's going to like make sure that there's no CI team that's going to write the tests for you or even write the jobs that run the tests for you. That's all stuff that projects that are hosted on OpenDev, their developers can create their own new jobs. And the nice thing about with Zool is that as soon as you write a change to create a job, Zool will start running that job. You don't even have to merge it because everything in Zool is speculative, even the job definitions. So you write a change that adds a job to Zool. Zool says, oh, hey, a new job, I'm going to run it. And if you merge that change, then that job gets run for all of the subsequent changes, right? So that's all very self-service, and it comes from this sort of philosophy in OpenDev of letting the projects manage that on their own. There's things that you can do on top of that. For instance, OpenStack has its own has a technical committee that sort of approves and sets standards for all of the projects that participate in OpenStack. And so there are some things that they enforce, and Zool also lets you do that. It lets you set some standards for sets of projects. That can all be accomplished in OpenDev as well. But just to get started to add a new job for your own thing, that's entirely self-service. We do have a standard library of jobs. So for instance, if you have a Python or Java program or something like that, we've got some standard roles and Zool jobs that you can just use out of the box. And that's also a great way to sort of contribute and share things with the community, because the more folks, for instance, the more folks on either on OpenDev or in sort of the wider Zool world that are doing things with Java, then submit. Like if you create a job to do something interesting with Java, submit that back to our standard library of Zool jobs and share that with everybody else. So we see all kinds of interesting things come through for that. Java, more and more things with Rust, stuff like that. So it's a really sort of interesting place to interact with other developers that share similar technology.
So we do have one more question from the audience. I know we're starting to run out of time, but I think it's an interesting one. So this viewer is familiar with Zool and Gerrit code review, and they think it rocks, which is great. So if one does build a Zool and Gerrit for projects that's not OpenStack, what are some of the challenges that they may run into, and maybe even some of the solutions that y'all found that can help mitigate those issues?
Yeah, so I think one of the things that motivates us running OpenDev is that, there are challenges. It's not to build up an infrastructure to support large projects is takes some effort, right? And so the idea behind OpenDev is that if we can collaborate together, then we can just spread that load out, right? You can help us out, we'll help you, and everyone kind of can be happy. So that's part of the motivation behind OpenDev. If you were to run this, say, for a non-open source project, or if you've got different requirements, I think just generally, running a Zool, and for example, I don't want to say it requires expertise. You'll have to learn how Zool works, I think, to do it reasonably well, just because as part of your spin up time and getting users familiar with it, you're going to have questions about, like, why is this job doing this thing, and what's going on in the system, right? So you need a little bit of familiarity with how Zool works. It's not just something you're going to deploy and then forget about it. And over time, I think that gets easier because your users will become more familiar with the tool, and they'll be able to help themselves and each other. On the code review hosting side, I don't know, Gerrit, in the before days, Gerrit was a fairly difficult service to run. Upgrades were very difficult. I would say modern Gerrit has improved tremendously, and it's a lot more direct. Again, not really set it and forget it, but as long as you're staying on top of an upgrade cadence so that you're on maintained versions of the software, running Gerrit is reasonably straightforward, which is great because they've had to put that effort in to get there. And then, go ahead.
Well, I was gonna say it depends somewhat on your tolerance for behavior changes and regressions too. I mean, the lifecycle management part of it is really the most challenging part for any systems administration. But for Gerrit specifically, like we actually run automated upgrade tests of the Gerrit software so that we can have confidence that when it comes time for us to upgrade our production Gerrit, that's going to work smoothly. And we've hit issues, regressions with upgrades and so on in the past that have have prompted us to and Clark more recently to go propose fixes to Garrett itself so that upgrades will actually work. We currently have more extensive upgrade testing of Garrett than the Garrett project does.
There are some resources that we provide. So if you wanted to get started with Zool, if you go to zool-ci.org/start, that'll link you to sort of a tutorial for how to get Zool up and running. There's that should walk you through the basics and give you a handle on what's involved in a Zool system. That tutorial actually includes a Garrett. Why does it include a Garrett? Because Garrett is open source and we can include it, we can make a Docker Compose file that you can just Docker Compose up this whole system to start playing with it. And that's only possible with Garrett. So that's a good way to kind of get started with all of this and see all of the moving parts. That's still pretty far from a production system. It is like you could turn that into a production system, but it's going to take a little bit of work. It's not intended to be an entire system in a box. That's kind of something that's going to be up to you. There's some amount of help you can get from the community in terms of mailing lists and IRC or matrix rooms, things like that. If you're sort of very motivated and you just need a little bit of technical help, that can be a great thing. I'm not sure that I would expect a whole lot of hand-holding for like how to get your enterprise system up and running from scratch from the community. That might be a bit much. You can, of course, because all of OpenDev's actual infrastructure for running itself is open source. If you want to see how we run Zool or how we run Garrett for the OpenDev Collaboratory, you can look at all of the Ansible roles and playbooks and container images and everything else that we do. That's all right there. So that's a great way to answer questions. And then there are also some commercial resources available. So putting on my my business hat, I have a company called Acme Gating, which is how I'm able to work and contribute to Zool. And what we do is help enterprises that want to run their own Zools. So I can help you get a Zool up and running and maintain it and scale it out and that sort of thing. Likewise, Garrett Forge is a good company out there that provides commercial support for Garrett as well.
You know what it means if I'm back. So I know we're almost out of time, but we do have one more audience question. So this is around the issue management system. So Songsu uses Launchpad and Storyboard at the same time, and wondering which system y'all plan to use mainly in the future.
So I think where we are at today is that we are happy with flexibility here. Like we aren't mandating or trying to mandate or being strict about what issue tracker project management type system you use. So for example, I'm pretty sure some projects that we host are using GitHub issues. They mirror their code to GitHub and then they're using GitHub issues. We still offer Storyboard. We're trying to keep it alive. And some projects are still using Launchpad. I think, all of those are reasonable. We would encourage people to continue using open source tools. Both Launchpad and Storyboard are open source. It is an area where I think we're open to feedback and contribution. If you can help out in improving, say, the Storyboard situation or integration with Launchpad or whatever, we'd be interested to hear from you. I'm curious to know if Jeremy or Jim have any other thoughts on that.
We do currently manage some integration for both Launchpad and Storyboard, insofar as we've got some automatic hyperlinking in Garrett web UI to to both of those, depending on how links are formatted. Automatic updating of tasks in Storyboard or of bug tasks in Launchpad, depending on what sorts of commit footers people put in their commit messages for changes in Garrett. But I mean, I'm like you. I'm aware of projects that are using other defect trackers and task management systems external to those as well. Jira is another popular one that some folks are relying on. Again, not open source, but popular nonetheless. So
I think this is a good example of sort of what it means to be a community maintained open source infrastructure. To put it very simply, if more people showed up and contributed code to maintaining and both the software and the deployment of Storyboard, then it would get better. But right now, that's not a priority for anybody who happens to be contributing, and so it's sort of stagnating and in a sort of low-level maintenance mode. We're the folks who are kind of the core OpenDev team. If the service crashes or something, we're going to try to bring it back up. We'll try to keep the thing running. It mostly does that on its own because that's the way software is written these days. But we're not tasked with adding new features or doing migrations to improve performance or things like that. Those are all things that anybody could come and contribute to. So it really, the priorities of OpenDev are the priorities of the people that show up and contribute resources and time.
And I think that's honestly a great thing to end on, because open source software doesn't exist without people. So I also just want to thank y'all, because y'all are the ones that have gotten it to where it is, among other folks in the community who've contributed as well. But definitely encourage folks who are watching, whether it's live or they're recording later, to reach out, figure out how you can help, and to keep this software running, because it is instrumental to existing open source projects, and I assume more projects in the future. So we are at time. So I wanted to thank y'all for joining us today. I have a few things to wrap up. But any last words from our panelists today?
If you need contact info, it's on opendev.org. So yeah, we'd be happy to hear from you, both if you want to use the OpenDev systems or if you'd like to contribute, or both.
have a great time with OpenDev.
Mm-hmm.
Yeah.
All right. Thanks, y'all. And like Jim mentioned earlier, events over the past decade have been where a lot of these conversations have taken place. So I wanted to kind of talk about a few of the upcoming events where you can meet these folks as well as other members of the global OpenInfra community. In September, we will have our first regional OpenInfra Summit Asia. This will be hosted in South Korea. Everything is live on openinfra.dev/summit, and we will be opening registration and sponsorship in the next month. We'll also be having a OpenInfra Days Europe Roadshow, where there will be multiple OpenInfra Days in Europe in May and June, where you can participate and learn more about some of the regional collaborations around open infrastructure. And last but not least, we do have a PTG coming up that will be virtual. I believe members of the OpenDev team will be participating in some pre-PTG, but also some PTG sessions. So if you do have questions, you do want to get involved, this is a great place to find Jim, Jeremy, Clark, and other members of the OpenDev and OpenInfra community to start collaborating. Thank you again for joining us today. And like Jeremy said, have a great time with OpenDev. Thanks, everyone.